Well, this is the type of problem that you should actually use a pencil with, because there's a little bit of trial and error sometimes. So the important x values here seem to be -3, 0, and 3. And it says that the y value is equal to 0. So that part I'm pretty sure about. I can put that in pen. Okay, next. So I'm done with those. Next, at -2, the derivative equals 0. So at -2, it doesn't say what the y value is, but the derivative equals 0. So I'll just put it up here. Derivative equals 0 means that it's got a horizontal tangent line. So I'll just represent that with a little tiny horizontal tangent line right there. The derivative at +2 does not exist. So that could be something like a cusp. And the derivative is positive on the interval from -2 to +2. That's the reason I need to be using a pencil and eraser, because if I connect this information with this information, it would be going down, which is not a positive slope. So this guy, well, one of them needs to change. Now I guess this guy has to change so that it can be going up. So this says it's going up, slope is positive on the interval from -2 to +2. So I could put something like that. Okay, that takes care of this whole line. Next, from -3 to 2, it is concave up. So I need to make sort of this shape from -3 to +2, which means me drawing a straight line right here is not quite it. Needs to be more like a U shape. So from -3, so I'm going to need to have it bottom out right here and then make a U shape. So I'm putting this at -2. I also need it to go through 0, and then I could have my cusp thing. Great, done with that part. And now on the right hand side of 2, the second derivative equals 0, which means it's not concave up and it's not concave down, but it could be like a straight line, is neither curved up or curved down. So it's neither concave up or concave down. So my cusp is changing a little bit. This side is cusp-like, and then this side is going to be straight line, so it's going to be like a corner. So it's a hybrid, half cusp, half corner. So the derivative doesn't exist there. It goes through the points. The derivative equals 0 there. This is concave up, and this is neither concave up or concave down. Well, it seems that I have all of the parts that I need. There's only one small problem. No, there's not. Yes, there is. There it is. I found it. The problem is right here, I can't just stop it right there because it says that it's a continuous function. This implies that the derivative exists. Oh, not at that. If this was a square bracket, that would imply that the derivative exists at -3. So then I would need to have this continue on a little bit so I have the derivative existing at -3. Technically, since this had a round parenthesis, then I don't need to, but it looks fine the way it is there with that extra completed part.